In this video, we're going to be looking at adding and subtracting polynomials. Our first two examples are on adding polynomials. So you see here we are taking a binomial and we're adding it to another binomial. Now they're both in parentheses, and if you think about it, if I look at the number in front of the parentheses, the coefficient, that would be a 1, and this would also be a 1. So is the distributive property necessary for us to rewrite this expression without any parentheses? The answer to that would be no. We really don't need to distribute a positive 1 because it's not going to change the expression. So the parentheses really aren't necessary when you are adding polynomials. So we can just take off those parentheses. So if I look at the expression with the parentheses taken off, it would look like this. And then it becomes very familiar because this is the same thing as combining like terms. So if I take a look at this term and this term, they're like each other. They can be combined together. It says 5x squared plus 8x squared, which would be 13x squared. And then if you look at the minus 3 and the minus 1, you can combine those together. Negative 3 minus 1 would be negative 4. And then I just want to double check that the expression or polynomial is written in standard form, and it is. We have the highest degree first, and if you look at the answer choices here, it would match up with answer choice A. So that's number 1. And then if we take a look at the second one, we're going to do the same thing. Noticing here that when we're adding polynomials, we really don't need the parentheses because this would be just like distributing a positive 1 and then distributing a positive 1 in front of here, and that's not going to change the expression at all. So it is not necessary when we're adding polynomials to distribute anything. We can just take off those parentheses. So just pretend like they're not even there. I'm not even going to rewrite this expression. We're just going to pretend they're not there. We're going to go right down to combine like terms. So I want, again, to be sure that my expression or my final polynomial is written in standard form. So I want the highest power first, and that's going to be this negative 8 to the x to the third power. And then I'm going to look through and I see that I have a negative 9x to the second power, and I have a positive 8x to the second power. So I'm going to combine those two. Looking at the coefficients, negative 9 plus 8 would be negative 1x to the second power. And then I'll look and see that I have a positive 1x and I have a negative 2x, and those two both have an x to the first power. They can be combined together. So 1 minus 2 would be negative 1x. And then lastly, I've got these constants, a positive 2 and a positive 4, and if I add those together, I get a positive 6. So we end up with a cubic polynomial because we've got the highest degree as the third power, and polynomial, we have many terms here. There's more than 3. So this would be what I would end up getting if I were to add those two polynomials together. So we took a polynomial and we added it to a trinomial, right? And because of combining like terms, we were able to end up with a polynomial. So this is how you add polynomials. You're just taking off the parentheses, combining like terms, and then writing your final answer in standard form. Let's take a look at subtracting. This is a little bit different. Okay, with subtracting, notice again how we have a trinomial here, and we're going to be taking away a polynomial, but there's parentheses around both. Now, if you look in the first parentheses in front of it right here, this would be just a positive 1. And it's really not necessary to distribute that positive 1 because it's not going to change the expression at all. But take a look at the second part. It says minus right here. See that minus sign? What number is in front of the parentheses that we don't see? Well, that's a 1. But because of the minus or negative in front of it, we're going to have to distribute. It's going to change this entire expression here. So if you notice, how do we subtract polynomials? The first step is to distribute the negative, and that's going to be in the second polynomial here. So I'm going to rewrite this, leaving the first polynomial the same, negative 6x to the fourth plus 5x minus 3. But then over on the second one, I'm going to be distributing that negative 1. So negative 1 times 2x to the fourth power is going to be negative 2x to the fourth power. And then negative 1 times 4x squared would be negative 4x squared. And negative 1 times negative 3x is going to make it a positive 3x. And negative 1 times negative 3 will make it a positive 3. So really what's happening by multiplying everything by negative 1 is you're just changing the signs of every number there in the parentheses to its opposite. Okay, and then what we'd want to do is to combine our like terms. So I want to be sure that I'm writing in standard form. So I want to grab the term that has the highest power, the highest degree first. And that's going to be this fourth power. Here and here, always look at the sign in front. That tells you whether you're adding or subtracting. So I have a negative 6x to the fourth power, take away a 2x to the fourth power. And that would give me negative 8x to the fourth power. Then the next exponent would be this one right here to the second power. And so I'm just going to drop that term down, minus 4x to the second power. And then we would have the x to the first power. So that's positive 5x to the first power and positive 3x to the first power. So 5x plus 3x, 8x. And lastly, we have the constant, which we've got the minus 3 and we've got the plus 3. And if you notice that minus 3 plus 3 gives you 0, we don't have anything at all. That's just 0. So this right here would be the polynomial that we end up with. And being that it's to the fourth degree, we would call it a quartic trinomial, being that it has 3 terms. Okay, let's take a look at number 4. We'll switch up colors to be fun here. Okay, same thing as we did before. We want to be sure that when we're subtracting, we want to be sure that we are distributing the negative when we're subtracting. So right here, there's your negative 1. Let's distribute this. So negative 1 times negative 8 would be positive 8x to the second power. Negative 1 times negative 3x is going to be positive 3x. And negative 1 times 4 is minus 4. The first polynomial will stay exactly the same. So 12x minus 8x squared plus 6. Almost running out of room there. Okay, then as you see here in step 2, we're going to combine like terms, always keeping in mind we want this in standard form. So it looks like the highest degree would be to the second power. So I've got a negative 8x squared plus an 8x squared. Well, that just gives you 0. So those really just kind of cancel out. Then I take a look at 12x and positive 3x. Those are also like terms, and so I would have 15x. And lastly, we have the plus 6 and the minus 4. Positive 6 minus 4 is plus 2. So then I end up here with a 2 terms, which is a binomial, and I have the highest degree is 1, so this would be a linear binomial. And that's what you end up with here. So just the most important thing here to remember when you are subtracting is to distribute the negative. Okay, so in summary, if you take a look at your notes there, you can go ahead and fill in the summary. Polynomials are always written in standard form, so highest degree down to the lowest degree. Polynomials are named with 2 names, the degree and the number of terms. And then I've got the steps here for adding polynomials. Remember how we want to remove the parentheses and then combine like terms. So just kind of checking off those and being sure you have those written down. And then subtracting polynomials, we want to be sure we distribute the negative and then we want to combine like terms.